Welcome back to the final lesson of Honors Algebra 2 Fall Semester 2019. It's been such a great semester, and this is our last run before the final exam and test. You can do it. Let's go.
All right. The first part I'm going to show you is not actually in your book, but I feel like I need to show you regardless. So we solved exponential equations, and we did what I called base manipulation, remember? Where if you had like 8 to the 2x plus 1 equals 1/2 to the, come on, x minus 5. How would you solve that? Make the bases the same, right? This would become 2 to the 3rd. This would become 2 to the what? Yay. And then we set the exponents equal and solved it, right? Do I need to go through and do that? Y'all remember?
Yes.
Can you put
Do it. Okay.
just around the other one? Or does it have to be, can you put the parenthesis around the 2x plus 1?
You can. You can.
Sorry.
All right. That's okay. All right, so when we solved it, we had 3 times 2x plus 1 equals -1 times x minus 5. And so we simplified each side. And then we solved, so I have 7x equals 2 over 7, right? Easy peasy. So, but now the question is, what if I didn't have the exponentials on both sides that way? In other words, what if I had, y'all got this? What if I had something like but then the bases aren't the same. You make a log. So here's what you have to do. Should you ever get stumped in solving, your go-to is going to be, can I change the form? Okay? So when you're solving exponential, that says when, I know it doesn't look like it, it does. When solving exponential, the first thing you want to do is isolate. What does isolate mean? Get it by itself. So isolate the exponential term. And in the case of this is an easy one. It's already isolated. It's already by itself. If I had maybe, and don't write this, but if maybe there was a 1/2 in front of it, I need to multiply both sides by 2 and get rid of it, right? So you only want the base and the exponent on one side. Once that happens, you change the form. This is where everybody always struggles for whatever reason. I don't know why, but everybody struggles when we go to change the form. What does this look like in logarithmic form? Log base 2 of 3. Logs always equal exponents. Well, are we all in agreement that log base 2 of 3 is just a number? It's a value, right? How can I find that value? Calculator. Log 3 divided by log 2. So somebody do it on your calculator and tell me what you get.
Where is log?
Change a base. That change a base formula.
What do you want me to round to?
2 places is good.
1.58.
5/8. Okay.
Now we can solve it.
Now you can just solve. It's an easy solve, right? Minus 1.58 equals, and then what? Divide by 5. What do you get?
1.
What is that? I get 1. Hold on. What was your 1?
This on your calculator is 1.58. All right, what do I do? Hold on. Log 3 divided by log 2. 1.58. I subtracted 1 here. And then I divided by 5. Does that make sense to everybody? So that's easy. That's not in this section in your book, but I felt like I needed to show you in case you encountered that. But it goes right along with logs, huh? Yeah. It is. It's super easy. Y'all want me to do one more?
Will you coach
Yeah.
class
Wait,
what
do
they
you
are
know
first
when you have
video?
to isolate the base?
I'll tell you in the class, yeah.
Yeah, can you do that?
Where you have to isolate? Yeah, sure. Let's say I had...
So there's only 2 steps.
And solve. Solve will be step 3. That's an E. No, I don't want to do that. I want to, I'm going to make this 16. You're writing in pen, I'm sorry. So what do you do first if I want to isolate? Add 5 to both sides. Remember, I'm SAD mapping. I want to isolate that exponential term, and this is the exponential term I want to isolate. That's what I want to get by itself. So you get 21 when you add 5.
Divide by 3.
See why I wanted it to be 21 now? And you're absolutely right. Now divide by 3 because that's still hooked to that exponential term. Still got e to the x plus 1 equals. Okay.
Second.
How you put what in your calculator?
Second spot.
Yes, but what are you putting in? What are you putting in for e? Okay, so I need to change the form, right? So if I have log base e of 7, what is the same thing as log base e? Natural log.
What is natural?
A log base e. If the base here is e, it's the same thing as a natural log. And there's literally a natural log button on your calculator. Natural log 7. It does the log base e.
It just changes the base of the
Mhm.
log, because usually the base is 10.
That's right. Good job, Marshall.
Alright, so log E always equals.
Log base e, yep.
So if you see an E, it also makes log base.
If you see an E is the irrational number, 2.71, da 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 da. But log base E is the same thing as natural log.
How can you go from E to log base?
Because E equals natural
I changed the
log.
form.
Oh, it's so
Log, the base is E of 7, and logs always equal exponents. You do, yes, you can, absolutely. Because that change of base works no matter what your base is, you can do it.
So E equals natural log.
Yeah, no. E is an irrational number. This would be just like saying log base 2.71, da, 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 whatever E is, of 7 equals x plus 1.
But
Kind of like pi, actually exactly like pi.
Okay, so natural log is just another symbol for E, right?
For log base E. Log base E is the same thing as natural log.
Is there
It's-
another form to use E in? Another way? Besides log?
Sure, we use it a lot.
In what?
We were doing it today with in pre-cal with compound interest.
So whenever you see log base E.
That's kind of like saying when do you use pi? It's a number. It's a number you use a lot. Yeah.
So
Is that like when it's continuously compounded?
You can do natural log. You can hit the LN button. Ava, I was trying to say Novi, said that she plugged in log 7 divided by log E and got the same thing. And that's
You can do
absolutely
that.
right because you can use change of base anytime. All right, subtract 1 to get x by itself. So are we hung up on the E or we talked about this, right? We did talk about log base E. Okay. I just want to make sure I told you I'm getting okay. Yes or no?
yeah.
Okay. Medium. Expanding and condensing. All right, I'm going to run through 3 scenarios with log equations. 3. Scenario number 1. You have 1 log term. 1 and only 1 log term. The steps for this are going to be exactly the same as the steps for solving an exponential equation. Let's say I'll start out easy, then I'll do a little bit harder. Log base 5 of x plus 1 equals 2. Okay. You'll always want to first isolate the log term. Where?
That's the 1.
How do we make it 5?
I knew it was real, but
Yeah.
I didn't notice it.
Yes, you're exactly right. You're exactly right. After we isolate the log term, again, we're going to change the form because a lot of times when we do this, the answer kind of pops out to you. So this becomes 5 to the 2nd power. Can you solve that now?
Wait, how?
You change the form. Remember when we did logs, I told you the key to being successful in this chapter is being able to change forms fluidly.
Yeah.
From log to exponential or exponential to log. Okay? So this is from log to exponential, and now all of a sudden it's an easy solve, right? 5 squared is... Mm-hmm.
And so that x plus 1, why did you move it to equal that?
Is that because it's the exponent?
What?
Okay, so log 5 x plus 1 equals 2. I know that 2 equals exponent because log equals.
Right.
So we get rid of the log. 5 squared equals x plus 1. Why does it now equal x plus 1?
What is it?
Is it just because?
This is in parentheses, so it's part of the log.
Okay.
Now, if it looked like this is different. And it's different because the log's not isolated. I would have to move the 1 over before I started. And then I could change forms and solve.
So would it be 5 equals x?
Yes. 5 to the 1st equals x, so
So if
x
there's
is
no
5.
parentheses, always assume that it's not isolated.
Right. You'll be able to tell if it's hooked to the log. Let's see. Your book just does not do a good job with logs, I don't feel like.
Did they not like talk to y'all about the book that they're gonna get? Wait, I've got too much time.
Let's do an example. Let's do.
Wait, is this another of the ones that?
This is an example. 1 log.
Are we still following the steps like isolate and change?
Yep. So notice you only see 1 log in this, so those are the steps I'm going to follow. Steps for 1 log. Isolate. So what do I do first as I isolate? Add 3 to both sides. Is it isolated? No.
Would you divide by 2 or would you add it as an x?
Okay, so you're thinking along the right lines. I'll condense in just a second in another scenario. Here, you just want to get the log by itself. It wouldn't be wrong if you did it that way. It's just going to be a lot more work. But if you did that, and then you changed forms, you're going to have to, well, you'd end up having to square root both sides. You'd end up with 4 to the 6th equals 5x minus 1 squared. Then you'd be square rooting both sides and going from there. It's just more work, but it's not wrong. It's just a little more work.
Do we subtract the 5x?
No, because see, it's in parentheses there. That means it's hooked with the log. That means it's part of the log function. So I'm going to have log base 4. Did y'all understand Meg's question though? Okay.
Because that's what I thought you did.
No, and that's fine. That's fine.
And you always want to do the
Then you do log
plus
base
3 on
4.
both sides before.
Yes, because you're solving. So think about solving. Yeah, SAT map.
And then you do log base 4.
So log,
Three.
always
And
remember
4 to
equal
the third
exponent.
equal to 5.
4 to the third.
Is that why, like, you wait a minute so you can, so numbers can be even?
You talking about whenever I'm writing a problem, whenever I'm coming up with it? Yeah, because I want it to divide and yeah.
And did you just do all that in your head?
Well, I knew I wanted it to come out. There's a problem in the book and it equals 3, but I knew I wanted it to come out to equal 3, but I wanted to multiply by something and add something. So yeah, that's what I was
Wait,
doing.
Mr.
Because I like it to come out nice and neat.
After we do push the 3 and the 5 at some point, do we drop the log and raise, and you see as a power? Or do we
Because
do
log
log
equals
base
exponent.
4?
Okay, so it looks like this. Log base b of a is the same thing as b to the x equals a.
So I
I'm
don't
gonna write that
I don't
down.
do log base of 4 to 3.
No,
I do.
you do 4 to the 3. All right, so 4 to the third is 64. Add 1 to both sides.
65 equals 5x, x equals 13.
Look how nice that came out.
No,
Yay.
Huh?
You're checking what divided by 5 is. Check that.
All right, 2 more scenarios. We're almost done.
Wait.
All right, scenario 2. 2 logs,
This is my favorite one.
You've got a square root these, right?
nothing else. Make a note. These are same base. This is the easiest one. I'll do one little example with it quickly, and then we're going to move on to the hard scenario.
So you put it from easy. And is that it for 4? I mean 6, 9?
Yeah. No, one more scenario. Yeah, this is 6-9.
We've had 9 lessons.
We skipped a lot.
Because we skipped it. All right, here's what we're going to do. Make sure, now this is all we've got. We've got 2 logs, nothing else, right? There's nothing added, subtracting, the same base. That's exactly right.
And then the next one's going to be a super.
No,
It's going to have stuff in it.
yeah.
It's going to be 2 logs.
So the log in the same number.
Yep.
Oh, that's easy.
As long as they're on opposite signs of the equal sign like that.
But if they're not, then what do you do?
I'm fixing to show you.
If they're not, would you like just set them?
Listen, you are rarely going to find yourself in this scenario. If you do, lucky day, congratulations.
That's gonna be our test.
Move on, okay? You may have one like that. That's not going to be the focus because that is super duper duper easy, but I just want to show you, should that situation occur, drop them off and do it, right? That's like me giving you exponential equations where the bases are already the same and you just set the exponents equal. Okay. All right, scenario 3. This is my favorite scenario.
Wait, I thought like last lesson was your favorite.
This is my favorite scenario in this lesson.
So she knows all.
Oh. Rather than
This is kind of the catch-all scenario. 2 or more logs. It could have more stuff in there, whatever it is, okay? It's just this is where if it's not scenario 1 or scenario 2, go to scenario 3 and work through it. All right, this is so much fun. Y'all are gonna love it. You ready? Let me get one that works.
I'm so sorry.
Thank you. Me too. Okay, let's say I have log of 5x plus log of x minus 1.
wait, is that log base 5?
What is the base there? Not a base indicated, so it's base 10. I've got 2 or more logs, and I've got some more stuff because I got a 2 there. Like, it's not as simple as just putting 1 on each side and dropping the logs anymore. Does anybody have any idea what you can do?
Wait, could you do like since they're added together, 5x times x?
Yay! Yes, that's exactly what you do. Oh, I'm sorry, I didn't hear you. Good job.
Maybe these always say stuff like, you always do it right. Is it 5x squared?
Here's what I'm going to do. I'm going to get the logs together and condense. Because my goal is to get myself back to scenario number 1. Scenario number 1 was only 1 log, right?
Yeah.
1 log is easy to solve because I can change the form and find out what x is. So if I have 2 or more, I need to condense. So you're exactly right. So this is going to be log times x minus 1. Right? Because that's how I condense. Condensing gets me down to just 1 log. So this becomes log. Look what we have, y'all. How exciting is this?
It's a parabola.
It's a quadratic. Yes, it's a parabola. It's a quadratic.
Now we can start graphing this, right?
We'll solve it algebraically, but you could graph it and. All right, so change the form. I get 10 squared equals 5x squared minus 5x.
Wait, what? Because base is the base of 10. Log.
Common log, there's no base.
And there's something there in
Oh, that's like one long term.
Because it equals x bar.
Equal to 2.
Oh, which.
Log always equals x minus.
Be able to change those forms. That's your key to success here.
You square root it?
All right. Well, it's a quadratic, so I want to make it equal 0 first, right?
Yeah.
All right. So I'm going to move this over here. So before I even do anything else, I see that they have a GCF. Yep. Get rid of it. What does this equation look like now?
Why did we say it equals 0?
Whenever we're solving a quadratic, we want it to equal 0 so that we can factor and solve or use the quadratic formula or any of those. It's an easy factor because there's no leading coefficient. That's exactly right. X minus 5, x plus 4. See why we spent so much time factoring in the beginning and we focused on that so much. Now I hope you can factor in your sleep. No, you didn't. You're telling a story. Don't say that.
I forgot.
Don't say that.
I never knew.
Hold on. So it's
Did you just say I never knew? Oh my gosh. Okay, what? No.
It's whatever you can, the numbers, what they equal.
I'm sorry.
That's okay. Correct. Okay, so because the leading coefficient is 1, normally we do a times c, which is negative 20. So we're looking for what multiplies to negative 20 but adds to negative 1. Negative 5 and positive 4, right? Because the leading coefficient is 1, I don't have to go through and group them the way I normally would. I can just put the factors in here. Now, if this coefficient was anything other than 1, I would have to go through and group.
What if it was?
You might even have a quadratic
No.
That's all chapter 3, right?
What?
That was all,
What chapter we in?
that was all chapter 3 stuff, isn't it?
Yeah. Or 2, maybe.
Chapter 3
What chapter we
is
in?
my downfall.
6? 7, 6, 7.
Not chapter 2 or 3.
Can our
All right, y'all want one more?
genius idea?
So is that the answer?
Yes, that's the answer.
Do ones that we have to use the quadratic formula.
No, can I do
Well, I want to
No, it is. I just don't understand.
Go. This is a good one. Yay! Try it. All right, if you're still working, continue to work, and we'll go ahead and work through it. I'm going to condense So I got x times x plus 3.
Why'd you do it in front of them?
It doesn't matter. You don't. It's just easier for me to see the distribution. That's okay. Whenever you condensed, you should have still come back to x squared plus 3x.
This is where that.
So whenever I change forms, I have e to the first equals x squared plus 3x. So whenever I move that e over, this is where it gets fun, y'all. I definitely cannot factor with an e because e is not factorable. There are not two numbers that multiply together to give you e.
3.76.
Because natural log is the same thing as log base e. No, it's gotta be e.
Because it's already lost.
Because it's already natural log. If it was just log without a base, you could do 10.
But E has a number.
It's 2.72.
Then you'll really want to keep e because if you start rounding it off, your answer's gonna be bleh. You have to round as irrational. It goes on forever and ever and ever. All right, opposite b. Plus or minus the square root of
Oh, man.
b squared minus 4
What is this?
times a, oh my goodness, times c.
Wait, I know this is to say b squared, but why is it a 9?
b is 3.
B, oh, right. All right. I was like, I forgot 3 was b.
All over 2a.
Is that a 9?
Yeah. Nine plus 4e. I would, if I'm doing it and I want it exact, I would leave it there. If you want the decimal equivalent, you most certainly may plug that in your calculator and do 9 plus 4e, take the square root of that, and then do negative 3 plus that divided by 2, and negative 3 minus that divided by 2, but as long as it's not a perfect square.
I was